Hello everyone, and welcome to this short introduction to using LangChain with Astra DB. So real quick for this short session today, we're just going to cover a quick introduction to everything, including all the things we're going to work with, as well as, some terms that would be good to know and understand. We'll also, take a quick look at LangChain, talk about what it's designed to do. We'll have a look at Astra DB, and then finally, we'll look at putting it all together in a RAG application. All right, let's start with our introduction. So there are three important concepts to understand before we start working with AI-powered applications. One is an LLM, or large language model. Another is vector search, or querying by like an embedding, by like a nearest neighbor, or making some other approximation. And finally, RAG, or Retrieval-Augmented Generation. Let's take a minute and talk about these 3 points real quick. So what is an LLM? So essentially, a large language model is a corpus of words built with a recurrent neural network. The idea behind it is that the LLM understands the relevance of the sequence and placement of the words relative to each other. So it can make sense out of certain words and their order, or certain phrases and certain repeated words. All of that plays in to getting good responses from your AI-based application. And an LLM also helps with the concept of generating embeddings, or a tokenization of the phrase or words that are entered in that we're trying to match up or find relevance to. How about vector search? So essentially, vector search works on data that has been transformed or tokenized into embeddings. And that vector search works on approximate matches in what we call vector space. And that can be based on indexes that are cosine based, dot product based, or Euclidean based. For a quick example, let's say that we have a website for a pet supply company. One of the products we might have is a Love My Dog ring chew toy. And another product we might have would be a Love My Dog tennis ball toy. So if we were to take those product names and create embeddings from them, let's say that we had just a simple two-dimensional vector come back. This could be a visual representation of the approximate distance between these two vectors and between these two products to allow us to assess how similar they are. So in this case, we would be using a cosine-based ANN, or approximate nearest neighbor approach, to our vector similarity searching. What is RAG? Well, RAG is something you're hearing a lot these days in the AI/ML world, and that stands for Retrieval-Augmented Generation. Essentially, it's information retrieval coupled with text generation. So the LLM that you're working with kind of has its prompts augmented with relevant data in the context. You see this used a lot, in like chatbots and other, like conversational-based AI applications. But essentially, RAG is a way to kind of, build on your interactions with your LLM and improve and increase its chances of getting a good and valid response. All right, let's have a look at LangChain. So just what is LangChain? Essentially, it's a framework for building AI-powered applications with large language models. The idea is that it allows for applications that are context-aware and can reason based on the context or the corpus of words in the model. So the big thing that LangChain does is it helps abstract a lot of the tedious configuration and tuning and a lot of that other, a lot of the more difficult aspects of working with an LLM. So it provides you with things like modular components and common methods and ways that you can, easily change in and change out the different models that you're working with, depending on the behavior that you're driving for with your application. It also gives you API access to both Hugging Face and OpenAI. So if you decide that you want to use an LLM as a service, LangChain can help you do that as well. So when you build an application with LangChain, it kind of looks like this, where you have, your application written in like, JavaScript or Python or, whatever. And it sends data to the model. So that's really how it works with LangChain, is it's making calls to LangChain. LangChain is kind of handling everything else behind the scenes. So LangChain takes care of interacting with the model provider and the model itself. It takes care of working with your vector store, in this case, DataStax Astra DB. So it will automatically do things like, creating and persisting embeddings, as well as invoking a vector search to go ahead and produce relevant data and then return that data back to your application. All right, let's take a quick look at DataStax Astra DB. So Astra DB is based on the Apache Cassandra project, which was really built around distributing data at large scale, and engineering for both read and write performance, providing that, linear scalability, high availability, and really being able to build things platform agnostic. So you can run Cassandra on your laptop or on a bunch of bare metals or out in the cloud or on like an internal private cloud and like an OpenStack kind of a thing. Cassandra is really versatile, and it's really used by a lot of big companies who have a lot of data. And Cassandra is what allows those large-scale applications to provide quick and expedient data as fast as they do. So let's move on a little bit here and introduce Astra DB. Again, based on Cassandra, it's essentially a Cassandra database as a service. It can deploy to all three major clouds, so AWS, Azure, and GCP. And it has a very robust free tier with $25 worth of cloud credits per month and 80 gigabytes of storage. So Astra DB is what we're going to be using for our vector database today. All right, let's take a look at an astronaut RAG application. So what we're going to do is build an AI-powered application to serve as a knowledge base of NASA historical astronaut data. And in order to make this work, I've split it up into two separate Python programs. One is the astronaut RAG program, which essentially is our interaction with our model and our conversational back and forth that we have with the LLM. And then, of course, we have our astronaut loader. And our astronaut loader is actually going to take a CSV of raw astronaut data and run it through LangChain, which will generate the embeddings and be stored in Astra DB. Important to note that both of these programs are going to interact with the LangChain library and leverage LangChain to drive all of the AI interactions going forward. So if we start with the astronaut loader, essentially what it's going to do is it's going to send text from a raw data CSV file out to our model, which is OpenAI. We're going to use OpenAI to generate our vector embeddings. Those will be returned into LangChain. LangChain will then persist those embeddings into DataStax Astra DB. Then, once that data is loaded, we'll go ahead and run that astronaut RAG program. So essentially, we'll have a conversational interaction where we'll trigger a query to be run, or a vector search, and that will actually be done through Astra DB. Astra DB will process that vector search and return the results to LangChain, and then our program will display the results. It'll be very simple. Let's take a quick look at the astronautloader.py program. We'll start with our imports from the LangChain library, specifically for the Cassandra vector store, because that's how we'll interact with Astra DB. We'll also pull in the OpenAI embeddings library so that we can work with OpenAI through LangChain as well. And we'll start off here by pulling in some environment variables, namely our Astra DB ID and Astra DB application token. And we're going to send those into our CAS.io init. Now, CAS.io is a layer that we've built that essentially works as like a bit of an interface around Cassandra and around Astra for LLM-based or LLM-driven applications. In this case, LangChain actually uses CAS.io to talk with Astra DB. We're going to create our embeddings down here and initialize our vector store as Cassandra. Then we're going to load our astronauts.csv file. We're going to process that file into a dictionary or array of lines. Then we're going to reprocess those lines just to pull out the name. That's going to be our unique ID that we're going to send along to our vector store. And down here in this vector store.add text, that's how we load the data into Astra DB. So essentially, that add text on the vector store works through LangChain to reach out to OpenAI to generate our embeddings. They get stored in a vector type in Astra DB along with the IDs of the astronaut names. So moving on to our astronaut RAG application here, once we pull in, library imports for, Cassandra and chat OpenAI and AI embeddings, we'll kind of have the same code as we did in the loader program to initialize our connection to Astra DB. We're also going to create an LLM object here and set that equal to chat OpenAI. Additionally, we're going to build a chat prompt template. Now, this is something inside LangChain that allows you to, provide additional context and definition to the AI and to how your chatbot or your chat model is supposed to respond with human interactions. And in this case, we're telling it, hey, you are a NASA historian tasked with answering questions from space enthusiasts. You must answer only on the provided context. You can't make anything up. And then we also tell it that it must refuse to answer questions on topics other than NASA astronaut history. Once we have that prompt definition, we can use it here with this chat prompt template from template method to create our astronaut prompt. Then we initialize our vector store, kind of like we did before in the loader. We can also set a retriever using the vector store.asRetriever, and we can add this all to our chain. And that's kind of the way that LangChain works, is that it allows you to quote unquote, chain things together in terms of how you work with and how you build out your AI models and interactions. So we're going to initialize our chain with a context of retriever and a question of runnable pass-through. We're going to send along our astronaut prompt, our LLM, and we're going to parse the output here with this string output parser that'll automatically bring our answers back. We'll actually seed our program with this first initial question of which 3 astronauts flew on Apollo 11. And then we'll essentially, repeat and keep invoking our chain with new input conversationally as long as there's input, and then we'll go ahead and break out of it once the user inputs the word exit. All right, let's actually check this out and put it into practice. So I'm going to go to astra.datastax.com. I'm going to sign in with my Google account. So now that I'm on DataStax Astra DB's dashboard, let's go ahead and create a database. I want to make sure that I'm selecting a vector database and not just a serverless database. And I'm going to name this database Astronaut RAG, just like that. My key space name is going to be vSearch. Going to have GCP as my provider. And I'm going to pick US East 1, Moncks Corner, South Carolina as my free region. And then I'll say create database. While we're waiting for that to come up, let's go create a token to access our database. We can go down to the settings gear icon here and click into that, and then I can click on tokens, and I want to say database administrator because we want our user to be able to create tables and indexes and everything that it needs to. And then I will say generate token. There. And then I will copy off those details. While I'm waiting for this to come up, I'm going to go to the GitHub repository for this project. And I'm going to have a look at my Cassandra table definition that needs to end up inside of my vector database. So here I'm going to copy this create table statement. And you'll notice it has a vector column that's of type vector, which is a 1536 dimensional float. This actually matches up with the default chat model that I'll be using through OpenAI. So if I go back to Astronaut RAG and I say console, so now I'm in through the CQL shell tool with Astra DB. Let me use our key space named vsearch, and then I can paste in my table definition. Now that table is there. In order for this to work properly, I also need two indexes created. One on the metadata S column, and another on the vector column. And again, I can copy and paste those both from the Git repository that I just showed. Okay, so now that table definition is there. So I can do a describe astronaut OpenAI vectors. And here we go. There is our table definition. And down here are the two indexes that we created. So as you can see, I'm in my astronaut rag directory. This is, where I've cloned the repository from GitHub. If I look at the contents of this directory, you can see that I have the loader, I have the rag application, and I have the astronauts.csv file, which has all of the data that we're going to load and generate our embeddings from. Now, before we get too far, there are three environment variables that we need defined here. The first is we need to define our OpenAI key since we are going and working with OpenAI. There. So I'll export that as OpenAI API key, just like that. Next, I'm going to want to set an environment variable equal to the ID of my database. So I'm going to go to astronaut rag, and I'm going to say copy right on this database ID here. And then I'll go back and say export, and we'll say Astra DB ID equals, and paste that in. All right, we're also going to want to paste in our Astra DB token. So we'll say export Astra DB application token, and make sure that we paste that in as well. Now we should be able to run our astronaut loader. So let's go Python astronaut loader py. There we go. So that's completed. Now, if I go back to here and say astronaut rag and CQL console, and again, I want to use my key space, so use vsearch. And if I say describe tables, you can see that astronaut OpenAI vectors table is the only one there. So if I say select star from astronaut OpenAI vectors, where and we'll say row ID equals, and let's go with a name of a famous astronaut. We'll go with Buzz Aldrin. And as you can see, there is data there for Buzz Aldrin. So there is his ID. This is the actual line of data that was pulled out of that file. So you can see that he was recruited in Group 3 in 1963. He's retired. He was born on January 20th of 1930 in Montclair, New Jersey. He attended the U.S. Military Academy, and he flew on Gemini 12 and Apollo 11. And after this is the 1536 dimensional vector embedding that was generated for this string of data right here. So now with our data loaded, we can start the RAG application. So our RAG application has started, and if you remember, the seed question that we prompted our chat model with was, which 3 astronauts flew on Apollo 11? Our application has started by answering the 3 astronauts who flew on Apollo 11 were Michael Collins, Buzz Aldrin, and Neil Armstrong. So now we can ask it questions like, which astronauts flew on Gemini 10? Michael Collins flew on Gemini 10. I would have thought that it would come back with one more astronaut because Gemini missions each had 2 astronauts, but that's okay. How about which astronauts flew on Gemini 4? Jim McDivitt. And actually, Ed White was the other astronaut who flew on Gemini 4 and made the first U.S. spacewalk. Oh, let's see here. Which astronauts flew on Apollo 13? Fred Hayes flew on Apollo 13. But also, it looks like it missed Jack Swigert and Jim Lovell, as they were also on Apollo 13. So it's not perfect, but it works enough that it can identify astronauts who did fly on certain missions here. I should be able to also say, when was Fred Hayes born? Fred Hayes was born on November 14th, 1933. Okay. How about which astronauts are from Indiana? Anthony England and David Wolf are from Indiana. And it should have also included Neil Armstrong. Which astronauts are from Minnesota? Dwayne G. Carey is from Minnesota. All right. Okay, that concludes our demo. As you can see, we were able to build, a conversational chatbot on a corpus of astronaut historical data. As for the resources for this short little video, you can always check out LangChain.com, specifically the Getting Started document. Has some real great instructions on how to get going and how to build out, some of these applications on your own. The code for the repository that I've shown here today, the Astronaut RAG program, is out here as well at github.com, AAR0NP, and that, in the Astronaut RAG repository. And then, of course, check out DataStax Astra DB at astra.datastax.com. And, you'll get a lot of great resources there to build out your own vector database application, with, again, a very generous free tier. And don't forget, we have the Cassandra Summit coming up in a few weeks, December 12th and 13th at the McHenry Convention Center in San Jose, California. So definitely check that out if you're in the Bay Area. And again, thank you all very much and have a great day.